fact, it's only people watching the recording. Hello, people from the future. I'm here from the past. How's the future going? Hopefully better than the past was. I'm Derek. I'm the community steward at ETH Denver. If you don't know that, who are you? Why is this the first time you know about me? Probably because Cami helped retweet this. Speaking of which, I'm joined today by Cami Ramos from Fuel. Cami, can you do whatever version of introducing yourself you like doing?
Yeah, for sure. Well, first, thanks for having me in
Yeah, you're fine.
Denver. First of many gang live streams. Yeah, my name is Cami Ramos. I lead DevRel over at Fuel Labs, and I've been doing developer education for now more than 6 years. And hyped to have new people learning about Sway and building on Fuel, and just overall getting ready to build at Denver.
Um, Speaking of biddling, if you would like to help biddle the number of people that have access to hear Cami share some wisdom over the next hour or so, I just posted a little tweet over in the chat. It would mean the world to me if you retweet that and put a little heart on it so that whoever follows you know that you are having a good time over here. We're going to get deep on smart contracts in just a moment, but this is also going to include a little bit of high level, a little bit of theory, because before we can dig into why Sway is not, it's worth switching from Solidity, trust me, is like the second half of the conversation. But the first half of the conversation is, well, why would I even want to switch? Convince me to get off the thing I already use. To be fair, a bunch of people you're explaining Fuel and Sway to are probably like not Solidity people. They're like maybe TypeScript or Rust people. And you get to be like, yo, you don't even have to learn that nonsense Solidity stuff. You could just use our SDK. So those folks take care of themselves. But first, let's take a step back. I want to like frame the audience here so that you can like explain things at a level that makes sense. My preference is that all of the stuff we do here at the ETH Denver streams is like newbie oriented, like a smart person that has no context. And so if, as you're explaining like why the benefits of a modular blockchain, maybe don't assume that anyone's ever heard of UTXO and define definitions like that as we go. You don't have to start all the way back at like what are nodes, what's hashing. We can like assume some blockchain 101, but definitely not 201. Does that make sense? It ain't your first rodeo. First, some shout outs to the OGs who are already here. Hi, Beam Me Up Now. Beam Me Up Now helped me not get rugged earlier today. So thank you, Beam. And Exodus is back, as always. It's been months of seeing you around. And Andre. Welcome, Andre. Who are you? I've never seen you around. Get in our Discord. What's your Discord name? Are you in our Discord? I like our community because it's small but mighty. And so I just recognize people by name at this point after doing community calls for like 4 months. Cami, is there any more setting the table before we dive in?
No, only thing is that, yeah, you can come in here barely knowing anything. We're going to kind of cover all the basics. We're going to keep it super simple. We're going to write a smart contract with probably less than 20 lines. We're going to walk through every part of the way, and there should never really be a point in this workshop where you're like, I have no fucking idea what she's talking about. Everything first in kind of like a presentation format where we're going to go over some core concepts, and then we'll start coding.
All right. I'm here for it.
Okay, cool. Am I good to share my screen?
Yeah, go for it.
Okay.
And y'all, please do ask questions along the way. Like the whole point of doing this live is that it can be like a bit of a back and forth. Otherwise, we would have recorded this and have the production quality be higher. So, I mean, if you're going to be here anyway. No, let's go Mystery Science Theater style. Boom.
Okay. Can you guys see this good?
Yeah, you're looking great.
Okay, great. I can't see the chat or the window with the Twitch anymore, so if anything, just feel free to interrupt and stop.
Okay, I'll be the audience.
Okay, great. All right, cool. We have a little bit less than an hour. It's going to be more than enough time. I just want to make sure that we have time to really talk through all this stuff. So, like I said, I'll give a better intro in a second, but today the focus is writing safe and performant smart contracts with Sway. And I like to always add the little subtitle, like writing blockchain applications in Rust, because Sway, obviously, unless you've already been in the Fuel ecosystem, it's probably a language you've never heard of before. But Rust is a much more popular, well-known language. And for me, it's just easier to get viewers to kind of understand the direction we're going to head in, since Sway is a smart contract language based on Rust. So that's where we're going. And the thing that I really like about Sway, and kind of what I'm trying to capture in this title, is that with some other smart contract languages like Solidity, for example, which is how I got started writing blockchain code, there's a lot of kind of hacks and hacks, I mean like kind of interesting or different or hacky ways that you have to do certain things, where it almost feels like there's a lot of tribal knowledge that you need to have to write really high quality code. And that's why there exists like this whole kind of process of audits and auditing firms and spending hundreds of thousands and even millions of dollars on getting audits, because it's such a precarious situation, right? Blockchain is an adversarial environment. You always have to think about things like attacks, especially when you're dealing with money. So the cool thing about Sway is that it really, at the language level and at the compiler level, does some things different to empower your everyday regular developer like you and I, who aren't necessarily going to spend, $500,000 on audits, and we aren't necessarily the best coders in the world, but with the help of the language and the compiler itself, it kind of holds our hand and gives us more safety and more kind of space to write really performant code without being like a master level coder. Real quick again about me, I lead DevRel at Fuel Labs, and one thing that I'm really passionate about, what I've been doing for a really long time, is developer education. Even before it was really, at least in my world, called developer education. I taught computer science education for K to 12, so from 7, 8-year-olds to 18, 19-year-olds for a really long time in the Bay Area. And I did so much around like web development to JavaScript development to Rust development to interesting things like IoT and VR development. So it's something I've been doing for a really long time. And this is why I love getting opportunities to do this, because it very much so feels like I'm back in the classroom, even though it's virtual. More about me is I studied computer science at Cal State East Bay, which you've never heard of it, and it doesn't even matter. And that's kind of one thing I always like to asterisk. It's like, I didn't go to Stanford or any school anyone knows, and it doesn't matter. It doesn't matter what school you go to, just do you, be the best at what you do, and that doesn't matter.
I will say, shout outs to East Bay though. Like I taught high school in the Bay Area, and so a bunch of our seniors would end up going to East Bay, of course. So like East Bay's dope. I mean, it gets a bad rap pretty often, but like it also has a high quality education program for a lot of departments. So it's like quit being, a bunch of people rag on it. They're like, oh, East Bay, it's trash. I gotta go to East Bay. But it's like, no.
Exactly.
I mean, sure, like there are things you wish were better about it, but like they still have Calc 1, they still have Calc 2, they still have like data structures and algorithms. Like you don't need to shill out for Stanford or whatever.
Exactly. That's kind of my whole thing is like, yeah, for people who don't know, for context, Cal State East Bay is like the school, the stereotype is like it's the school that you go to if you couldn't get into any other schools, or if for some reason like you wanted to, kind of stay home and not go out into the world. So it always got a bad rap, like, oh, if you're so smart, you would have gone to Stanford, especially in the Bay Area where there's Stanford, there's Berkeley, there's like, a bunch of private schools. Anyways, I went to like the regular school and I did fine, I did amazing, and I have my dream job. So don't focus too much on the school. And finally, I was on the engineering team at PayPal for some time, where I worked on the checkout team. So I do have kind of that formal like Web 2 engineering experience before I started to do crypto. Okay, so before we get into it, one thing that you might think is going to be like a huge topic in this workshop is like modular blockchains and what exactly that means. But really, that's such a small part of what we're going to talk about today that it only deserves one slide. Why? Because as a developer at the application level, hold on, is there a lot of background noise? Let me close my door, I'm sorry.
Yeah, you're good. I was dead wrong. I thought it was going to be all about modular blockchain.
Yeah, exactly. Oops. A lot of people think that because it's such a small, like almost irrelevant part of, like I won't say irrelevant, but it's such a small part of understanding Fuel, because Fuel at the end of the day is just another blockchain. Fuel at the end of the day is just another environment for developers to write smart contracts. And getting too deep into blockchain architecture is not relevant for 99% of developers, right? Like, you don't care about how your blockchain is architected. You just want a good developer experience when you build applications on top of that blockchain. So for example, no one is like, let me read into the application and into the architecture of Polygon, right? We don't really care. We just want to know, are there going to be cheap, fast transactions that are ABM compatible. Like I can write in Solidity. Yes. Okay, that's all I want. And similarly, that's kind of the vibe here where it's like, this is a kind of, one pager on blockchain functions and how modular blockchains work. So just to give you the TLDR, traditional, what we'll call monolithic blockchains handle all 4 functions all in one layer: execution, data availability, settlement, and consensus. Now, the thesis of modular blockchains is that what if instead of every blockchain or a blockchain doing all 4, what if we could modularize it or pull some of these apart so that a blockchain can focus on one specific function? And that's exactly what Fuel is. Fuel is a blockchain, just like any other blockchain, but instead of worrying about data availability, settlement, consensus, Fuel only worries about execution. So basically what that means is it's the environment where you write smart contracts. That's all it is. And here are kind of the 3 pillars that we're going to get really into the Sway language part, but I think it's just still a nice overview, even though we're not going to get too into the details with this. So Fuel, we call it a modular execution layer instead of maybe some other terms that are out there as like a layer 2 or a roll-up. And the reason for that is because we're not a traditional roll-up or a traditional layer 2 for a lot of different reasons. The main reason and what makes us modular is that instead of Fuel being built specifically, let's say for Ethereum, in a way that Optimism and Arbitrum, for example, have, we have been built to be agnostic in such a way that you can plug Fuel in to be the execution engine for any system. So for example, Optimism and Arbitrum were built to be tightly coupled with Ethereum, right? They use the same language, they use the same virtual machine. If something in the EVM changes, that's reflected on that layer 2. But with Fuel, we have our own virtual machine called the Fuel VM. And because of that, we're not tied to any one implementation or architecture or system. We just handle execution, but we're not tightly coupled with any other system. So the other 2 kind of pillars that are interesting is we have parallel transaction execution, which basically means that instead of waiting for transactions to be executed one at a time, so for example, I'm going to send you 1 ETH, and then you send someone else 1 ETH, and then Josh sends Billy 1 ETH. Traditionally in EVM, those would all be executed one at a time. First, you would have to wait for one to finish, then the next one would start, and then when that one finishes, the next one would start. With Fuel and the design of the Fuel VM, and because of some interesting implementation details, which I won't get into, you can actually execute multiple transactions at the same time that don't have dependencies. So for example, if I send you 1 ETH and then you want to send that 1 ETH to somebody else, there's a dependency there where obviously that can't get executed in parallel with other ones because first you need to receive the ETH from me. But in a situation where there are no dependencies, you could execute multiple transactions at the same time. And then finally, the last pillar, which is the one we're going to focus on today, is the Sway language, which, as a reminder, is a smart contract language that is based on Rust. It's super familiar to Rust. It's also really similar to Solidity. A lot of people describe it as if Rust and Solidity had a baby, it would be Sway. And I love this meme because I couldn't find like the blank version of this, so I tweeted. I was like, how do I find like the meme where they're shaking hands? And then somebody just made this for me, and I was like, oh, this is perfect. But it like captures it so perfectly, where it's like, okay, we have Ethereum, we have the blockchain ecosystem that we know and love, and then we have Fuel, and when you put them together, you can have this superior developer experience without leaving the Ethereum ecosystem. So instead of maybe what people call like alt L1s, which is like going to a whole other ecosystem, maybe like Polkadot or maybe like, whatever the case, a lot of developers don't necessarily want to do that because they like the Ethereum ecosystem, but they do wish they could have certain improvements around developer experience or maybe around the language. And that's exactly what Fuel brings. So it's like, stay in the place that you like, but also like get some more features and quality and maybe different language features that you are looking for that you can't necessarily get off Ethereum alone. Okay, these are going to be the core concepts we're going to talk about, but before we get into them, the reason why we're going to talk about these concepts specifically is because they're the ones that I think are the most interesting. But as we go through these are going to map one-to-one with the smart contract that we're going to be writing here together. So today we're going to write a super simple counter contract which just has 2 functions. One gets the current value of a counter variable, countering 0, 1, 2, 3, 4. And then another function will increment that counter. So you can imagine like a UI where there's a button that says increment, and every time you press that button, that counter goes up, starting at 0. and then maybe on the 10th click, that number should say 10, and you want to have a way to get the value, like, okay, how do I know what to display to the user? How do I know what's the current count that we have at this moment? It's that function that we're going to define that's going to get the counter. So when to get the current counter and when to increment the current counter. And as we go through these core concepts, we'll talk about how that would look like, and then we'll actually build the contract at the end. So cool, core concepts. We're going to talk about the different program types that exist. We're going to talk about ABIs, immutable variables, how you define a function, how contract storage works, and this concept of namespace storage access. So this has a lot of words, and I debated putting it in because it's mostly irrelevant, but I think it's just an interesting thing to kind of check out about Sway, even though we're not going to get too deep into it. But with Sway, there's 4 different types of programs that you can have. You can have contracts, libraries, scripts, or predicates. I won't read off every single one. I'll just do the one that we're going to write today, which is contracts, which is just a regular smart contract that you're used to if you've ever written in Solidity or any other smart contract language. And if you haven't, you can think of this literally as your main executable file in any other language. Like if you're coming from C++, it would be like your main.cpp, or equivalent of Java, or whatever the case. So it's just your regular file where you write your code. So all .sw, which is the extension for Sway, files have to start with a file type declaration at the top. Because there's 4 different types of files, the first thing that you should do when you're writing in Sway is define what type of file this is going to be. And again, I said this is going to map directly with our smart contracts. This is literally a screenshot of that smart contract that says on line 1, we're literally going to write the word contract, semicolon. Boom. Now the editor knows we're going to write a smart contract, and it can have kind of like all the relevant things that are necessary versus maybe another program type. Okay, the next core concept of this is this concept of an ABI, or an application binary interface. And in Sway, at a practical level, what it is function definition and return types without actually implementing the body of the function. So basically, what does that mean? It means we just want to define things like the name of the function, the arguments of the function, and the return types of the function. Now you'll notice there's like these weird little like pound symbols and weird like brackets, which we're going to talk about in a couple of slides. So just like try to ignore those for now and think about how here we're not actually implementing or defining how this function increment works. There's no body here. We're not saying like, here's what should happen when you call increment. No, we're just saying there's a function called increment, which returns nothing and has no arguments. And then there's a function called getCount, which has no arguments and returns a U64 type. That's it. That's all you do with your ABI. Okay, next thing that's kind of different and interesting about Sway is that by default, variables are immutable. So what does this mean? Is that once a variable is declared, its value can't be changed during the execution of the program. So if, for example, you have a variable called name and it starts off as Camila, and you want to do some logic so that at the end of the function it's like, I don't know, my brother's name. In order to do that, you would have to consciously make that variable mutable. So it's not that it's impossible, it's just that by default, variables are immutable. And this is one of the ways in how Sway encourages safe programming, and a lot of modern languages now have the same default. So again, you can make it mutable, you just need to add this mute keyword that says, hey, me as a developer, I'm consciously, actively making the decision and the design decision to know that this will change. Now, what does that force you as a developer to do? It forces you to think about all of your variables ahead of time, and it kind of forces you to think about the design that you're implementing instead of just kind of like getting there and starting to write. You have to think, like, is this variable going to change? Where would it change? Why would it change? What would it change to? Are there cases where it shouldn't change? Are there cases where it should 100% change every single time? So it kind of forces you as a developer to think more deeply about your program from jump. Okay, how do you define a function in Sway? So remember we said that we're going to write 2 functions. One was going to be called getCount, which is just going to get the current value of our counter. So functions in Sway are declared with the fn keyword. So you see here, we see like fn is the keyword, followed by the name of the function, followed by the arguments, in which case right here, there's no arguments, followed by the return type, because we're going to return a number. So U64 is the data type we'll be returning. And here we're actually defining the body of the function. Here we're actually saying, this is what my function should actually do to get that return. And this might not make sense here, but you'll see in a minute how this returns the variable that we're looking for, the value we're looking Okay, contract storage. If you've written in Solidity before, you know this concept of contract storage. And if you haven't written in Solidity before, the concept of contract storage is basically persistent storage. So what does that mean? It means that at the end of a function that gets called, or at the end of your program, that is certain like pieces of information are going to persist, or they're going to stay. So for example, in this counter example, we want it to be an application, right, where anyone can come and press that increment button and the count will keep going. It shouldn't be that, oh, if I close my browser, it resets to 0. No, we want this to be like a globally shared application. That's kind of the whole point and ethos of blockchain, is that it's this like global computer, right, where we can all access. So it's like, it wouldn't really make sense if you had a counter, but if I close my browser, it reset every time. No, I want it to be that no matter what I do, this value is saved globally and anyone can interact with it. So the way that you do that is through what's called contract storage, or AKA just storage, is what kind of it's colloquially called, just without being so formal. It's just called storage. I don't know if you heard that, but that was a huge thunder that just went outside.
That was actually thunder?
Yeah.
Okay, I was like, that's either somebody moving a giant table upstairs or actual thunder. And it has
No, that was thunder.
Oh, you good?
Yeah.
Just see like a lightning flash and then your stuff explodes and then it cuts out.
Okay, so in Sway, you define all storage variables in one visual block in your files. What do I mean by visual block? I mean literally visually, it's all in one section of your file. So it's not like, oh, some are defined here, some are defined on line 12, some are on line 23, some are on line 45. No, they're all one after the other. And in our case, the only storage variable that we want or that we need is a counter, right? We don't have any need for any other one, so that's why you see there's only one. But in theory, we could have 2, we could have 10, we could have 20, we could have 100, we could have as many, okay, not like an infinite number, but in theory, right, like here's where they would all go. In our case, like I said, we only need one storage variable, which is counter, which again, in our example, this is the variable that's going to keep incrementing and incrementing as people press that button. And finally, the last core concept is this idea of namespace storage access. So that's the weird brackets that we were talking about earlier, and all it is that functions must annotate the storage access that that function has. So again, when we're talking about storage, we mean this. And why would you want to do that? Why would you want to kind of have to annotate every function? Again, this is another way in which Sway as a language forces developers to really think clearly about their design and say, okay, for example, the function get count, like get the current count, does that need to ever write into storage? No, right? Because all we're doing is we want to get what's already in there. I don't ever want to write to storage from my function get count. That's not what the function was made for. But on the other hand, the function increment, which the whole point is to increment that storage variable, I do want to be able to write to storage because I do want to be able to change and increment and update that. So you'll see here,
what?
Get count. Yeah, no, this happens. It's fine.
This happens?
Yeah.
Okay.
For this function get count, all we want is for this to have read access to storage. But for increment, we want it to have both read and write. And the reason for this is because, like what I just said, but also there are times where you'll notice, like a lot of times in Solidity, it's a pattern to have like a storage variable, let's say called counter, and then to have a local variable called maybe like counter underscore. And although they look similar, they're managing two entirely different things with different consequences. So you might accidentally increment counter underscore when you meant to increment counter or vice versa. And then that can lead you down a whole rabbit hole of bugs and things that you're like, why is this behaving so weirdly? So this is another way in which Sway and the compiler kind of holds your hand and it's like, no, that function isn't allowed to write to storage. Illegal, cannot do. Okay, so now that we've gone through the theory part, now let's just write some code. We still have so much time. And just for people, I'm going to drop this link in chat. Maybe I can do that. Let's see if I can do that.
Mm-hmm.
I'll just put it here, Derek.
Sure, I can do it.
That is the link to the resource that we're going to follow. If anyone wants to follow along or if they can't see my screen or something, that's what we're going to do. So I'm going to go ahead and share my entire screen for this part. Oh, unable to screen share. Maybe window. Let's see. Okay, no. No.
Nar.
No. Okay. Can you guys see my VS code?
And boom.
Okay.
Wait, it's still black though.
It says, please ensure you granted all necessary permissions. I did. Um,
There was a question, is that Bay Area Thunder? Yes, I believe that's Oakland Thunder specifically.
oh no, it's actually Columbia Thunder. That's an alpha. I haven't even talked about it, but I moved to
What?
Columbia. Yeah.
I was like, since when is the Bay having a thunderstorm right now?
No, yeah, it's actually Columbia.
Whoa, clip it. Cami just leaked the alpha. This is straight from Columbia.
Yeah, I was writing a whole blog post about it too, but I guess
Whoa.
now I'm.
Yeah. We said it here, and therefore you don't need to write that blog post.
Dude, why the frick can't I share my screen?
Just try again. Maybe the click stop and then bada boom. Any other questions for Cami? Oh, put me on the left. Zoop. While we sort that out, and then boom. Okay. So close. So close and so far away.
Okay, so I can share my one browser window. Can I share my whole screen? No.
Really?
1 second, let me see.
You should be able to. Question from my beloved Beam Me Up Now. How does it perform on gas optimization, though? There are plenty of people basically playing code golf out there with Solidity. I'm getting in context clues what you mean by code golf. Is that just like not being very gas efficient? Beam, you gotta clarify. Your joke's going over my head. Like a good putt? For anyone looking for the like killer feature of developing, it's the fact that it's in Rust. And if you don't know much about Rust, then let me tell you, it's developers' favorite language like 6 years in a row by a long shot, specifically because the compiler's super good. And so instead of getting like I'm not enough of a developer to know what like your average JavaScript compiler error joke would be here. Some kind of like garbage collector thing maybe. Or like memory thing. But like in Rust, it's like, hey, this specific part you messed up, and here's a recommendation I have of how to prove it. And you're like, oh, thanks, compiler. That's really nice of you. So in exchange for how much harder you have to work to get started, like in both in terms of learning and in terms of writing, it's like a little more verbose. That's all for the best, because that extra work up front saves you dividends of work down the line in things that you can be guaranteed are like type safe and errors that just literally cannot happen in terms of mutability.
Is this working?
No, it's black again.
So
Life is chaos. Can we please get some F's in the chat for Cami's inability to screen share?
okay, you know what? We actually just released like a beta version of using Sway in the browser. So let me see if I can get that running right now. Actually.
Oh, see? Necessity is the mother of invention. Now we get to try the beta browser IDE for Sway. Watch out, remix.ethereum.org. Here comes Sway.
Yeah. Okay, I don't know how well this is going to work, but I'm sure I believe in it. Let's just do it.
Okay.
Okay, I'm going to share that window since I know for sure that window works.
Yeah. Okay. And then while we're doing that, if you're enjoying this and you want to show your gratitude to Cami, then go ahead and retweet that tweet I just put there so folks know that we're doing this. Yeah, we're in.
Okay, cool. So sway-playground.org, it's a beta. It just kind of got released recently. So we're going to test it out together.
Nice.
So
Can we crank the text sizes like maybe 2 or 3?
Yes. Good call. Is that better?
Boom. That's amazing.
Okay, cool. I can't share that part of my screen, but I shared, or Derek helped me share the link to the guide that we're following. So if you wanted to go do this later, or you just are not sure where I'm getting this code from, it's all in there. So I'm literally just going to copy over the code because it's just a few lines, and then we'll talk about it and go through it together. So we'll delete all this. All right, cool. So this is the entire contract, 26 lines, really 25 lines, really like 23 or 4 lines without all these spaces. But let's talk through this together. So remember we said in order to write any sway file, we have to start off by declaring the type. Here we're writing a contract, so that's our very first thing. The next thing that we do is we define our storage variables, which again, on this specific contract, there's only one, which is a counter. But again, here we could have, I don't know, we could have likes or something like that. And in theory, have like a different one here, and that gets persisted in storage. But I'll go ahead and delete it just to not confuse people. But this is where they would go. And now the next thing that we do is define our ABI, which remember, if you recall, this is the application binary interface where we define a few things like the function name and return type and arguments, but we don't actually implement the body of the function. Now, the idea behind doing that is that in theory, you should be able to pull this out into a library. So maybe if I had, maybe one called like, I don't know, scientific math, and then I had like a bunch of cool functions like, I don't even know scientific math, but like
square, just
addition,
like square
right?
something.
Yeah, triangle addition where you have like 3 points and like you want to do some like very specific type of math on it. You could define your ABI here, and then now if someone else comes along and they're like, oh, I'm working on, I don't know, some calculus application, and instead of rewriting this whole library for doing triangle addition, I'm just going to use this ABI that someone else wrote and pull it in. So that's the concept behind an ABI. But here we're just going to define it directly in this file. 1, because I can't share my screen, but 2, because it just makes it more simple. So here in our ABI, we're calling a counter. We're defining 2 functions, increment and count. This actually makes more sense to be called get count, because that's really what it's doing. You'll notice for increment, there's no arguments because it doesn't need any arguments to increment. And there's also no return type here. And then for this one, get count, there's no arguments, but there is a return type of U64. Now, why is it U64? Because that's the type that's here. If this were something else, like literally anything else, that would be the return type here. But because the whole point of this function is to grab the value of this, we need to make sure that these match up. Okay, cool, and now we get to the implementation part. Now we get to the part where it's like, let's actually write how these functions work. And then you'll notice here, we actually also defined the storage access. So increment has access to both read and write, and get count only has access to read because we don't want this function to ever write to storage, but we do want to be able to read from it. Okay, down here we get to implement. So we'll do implement counter for contract, and here's where we actually implement all the functions. So if here we have 2, then here we should have 2. If here we have 5, then down here we should have 5. If here we have 20, down here we should have 20. So since we have 2, that's what we're going to do. The first function is count. And what does this one do again? This one just returns the current value of counter. Now, you might be wondering, all it does is says storage.counter. You might be more used to seeing something like this, return storage.counter. Mm-hmm. And that's perfectly valid in Sway as well. This is just a shorthanded Sway where you don't need that return keyword and you don't need that semicolon. But for simplicity's sake, I do like to put it just so that it's super clear, especially for beginners. So what we're doing here is we're literally just saying, hey, when this function gets called, all I want you to do is return storage. So boom, we go up here, dot counter, so we access the variable name counter. That's it. Right now it's 0. Let's say we started at 100. On the very first time it gets called, this would return 100. But we're starting it at 0 just because that makes more sense. Okay, cool. And then finally we get to our function called, mistake here. So because here in my ABI I called it count, I have to make sure that those match up. So we fix that. And now finally for our function increment, remember this is the one where we're actually going inside of here and saying, hey, do something with this, make it more, make it bigger, give me more, like Britney Spears. The way that we do that is we access it just like you would if you're coming from JavaScript, or I think literally, I don't want to say every language, but most languages I've ever seen, where it's this dot notation of like the object, and then dot the specific value. So storage dot counter, because remember here we could have had, right, so let's just leave it like this for now. in order for the program to know exactly what you want to write, exactly what you want to update, you have to let it know. So instead of it being like, hey, is it likes or counter, we have to say storage.counter equals storage.counter, so whatever's currently there, plus 1. Boom. And now we've done it. That was it. So we've implemented 2 functions, one that gets the current and one that increments. Let's compile this, and here's the moment of truth. It did it. It fucking did it. So this was able to build successfully. Usually you would be running this in like your VS Code, and you would run a command called fork build, and that's the point in the program where it would tell you if it was successful or if there were any errors that you would need to address. But again, this isn't the normal setup, but it's pretty much the same. Instead of pressing a button, you would just write in the command line fork build, and then when you're ready to deploy your smart contract, you would run a command called fork deploy, and you would go through a really easy flow there. Actually, let me just try to see if I can share this part of the screen for that. So now we saw I could build it. Here's how you would build and deploy it. So here, deploy. So let me show you how to build it. So I also have a step for testing it, but we're not going to write tests right now because why? So yeah, for build, you literally just make sure you're in the right directory, and then you run the following command. Oops, what was that?
Fork. What does FORC like mean?
Yes, good question. Fork is it's like shorthand for fuel orchestrator, and it's kind of the equivalent of npm coming from JavaScript, where it's like the orchestrator, the thing that manages all of the commands and that manages everything that you can do from the command line, basically. So you'll see we use fork build, and if everything was successful, it would say compile the library, blah, blah, and here's the bytecode size. I'm actually interested to see, it doesn't tell you the bytecode size here. Okay. Anyways, so boom, then this would be green in the command line where, all right, cool, I'm ready to deploy now. You wouldn't actually write tests because who writes tests? Then when you get to deploy, it prompts you to download or install the wallet CLI, which basically gives you as a developer the ability to sign transactions from the CLI because, right, in blockchain, you have to have this notion of signing these transactions, and so we know who actually deploy this. So you just follow some steps to get the wallet CLI, it's super easy. And with that, you'll get a fuel address that looks something like this, fuel, and then a bunch of numbers and letters. You would go get some testnet coins, just so you have enough tokens to actually deploy. And then after that, you would run this command, fork deploy. You'd pass in the endpoint, which for us is node-beta2, because we're on the beta 2 testnet. There was a beta 1 testnet, but that one came out before, and now the recommended one is beta 2. And we use a GraphQL endpoint, which if you don't know what that means, it doesn't really matter. It's just for people who care about that would matter to them. And then we set the gas price to 1. We set this flag just because of the gas price. The gas price is 0 by default, and you can't have it be 0 because you need to pay gas in order to get your transaction included. That's like another general rule of blockchain that doesn't really matter. That's why I just copy and paste this. That's what I do. And then after that, it'll ask you, hey, give me the wallet address that you want to sign this with. I'll give you back a contract ID. And this kind of goes into specifics of like how a message is signed. But basically, this is what it would look like. Fork wallet sign, you give it the contract ID, which is the one here. And then 0, which is like just a specification of how you use your wallet, which we don't have to get into. You enter your password, and then finally you get a signature. And now you have what you need to deploy it, and then you can actually go view your deployed contract on the Block Explorer. And then you'd be done. And then this guide also walks you through how to build a front end using our TypeScript SDK, which is also super simple. And I'll just scroll down just so you can get a view of it, but it's maybe like 30, 40 lines to build a front end in React or any front end that you're comfortable with. But we have a TypeScript SDK, so that's what gives you kind of the functionality of doing things like, how do I call a smart contract function for my front end? How do I do things like, block size or timestamp or something? Would be through that SDK. And then here is what it would look like when you're done. You would have a counter, this this could say whatever in theory, but I have to say counter because I'm representing the counter number, the counter variable, and then a button that says increment, and when you click that, that number should increase. And that's it, you've done it. You built full stack dApp, or at the very least, a smart contract on Fuel. Yay.
Yay.
We just did so much in like 40 minutes. See, and that's kind of the vibe that I like giving on this. It's just like, it's a new language and it seems scary, but when you really get into it, it's kind of like writing any other language, and it's really not something that's super out of this world.
Okay, so we've addressed the concern, Sway, a new language I have to learn. You made a good case for like, okay, you got to make an ABI. That way we know what we're looking at. And it also makes it easier for other things to look at it later. You pointed out a few of the quirks that are for your own good in terms of having to talk about like storage. Does it read? Does it read and write? It's for your own good. Think about it. And so it's like, people might be like, oh, what? I got to write extra things and think things. But like it ends up paying dividends later for reasons I won't even pretend to appreciate. What else should people know about, like, let's say, okay, yeah, at the next like Biddle-a-thon or hackathon I go to, I'm going to try my hand. I've got enough of a background in Rust that I'll go try out your tutorial. And then when I'm forming a team, I'll write my smart contract in Sway. I think there's this other piece of the narrative that I literally don't understand, which is you had alluded to Fuel being something which can be used in different ways. And so when you said like, and now it's deployed and you can go check it on the Block Explorer, my brain was like, deployed where? Like, is Fuel in L1? You talked about how it could work with ETH mainnet. And so I know it's not literally like we're a side chain, just like Gnosis chain. Come over here. So how is it not quite that? How are, like, what am I missing?
Yeah, so I think the key thing to understand is that all of these chains like Optimism and Arbitrum and Fuel and Ethereum, they're all blockchains in and of themselves. The label of layer 1 or layer 2 or side chain or this or that, they're all details of how they were implemented and their relationship to maybe Ethereum in this case. But at the end of the day, they're all still their own blockchains, and therefore they're all their own like networks in that sense, right? Like Ethereum is a network, it's a blockchain network. Okay, it's not a blockchain network, it's a blockchain, comma, / or network. And in the similar vein, Fuel is exactly the same. It's just another blockchain. So when you deploy something, it's actually being deployed on the Fuel network. Just like if you deploy something on Optimism, it's actually deployed on the Optimism network. Or if you deploy something on Arbitrum, it's actually deployed on the Arbitrum blockchain. So same thing. So it would be deployed on Fuel, and yeah, when we say kind of like modular and it can be used in different configurations, it can be deployed as an L2 as a rollup on Ethereum. In theory, it could be deployed as an L2 on Polkadot. In theory, it could be deployed as a monolithic L1, which we wouldn't do. In theory, it could be, it's like taking a really sick engine for a car and being like, I can use this in any car that I want, because all it is an engine.
Is it possible to explain less analogously and more literally what, like, maybe we could start somewhere simpler. Because my blockchain knowledge, like from an architecture perspective, is like zero. And so when I say, oh yeah, like Optimism like does compute and then like settles on layer 1, like I don't really understand like in what sense that's true, or like where state is being passed or when. And so if you could start with a simple example, which is like how something we would colloquially call a layer 2 is related to the layer 1, then I think we could maybe bridge that over to like how Fuel could be used as an L2. In other words, like not as the settlement layer, but as the execution layer. So how do the settlement and execution layer currently talk to each other in some other example, like either just ETH mainnet or ETH mainnet plus Optimism or Arbitrum?
Yeah, so generally, and keeping it super simple, because it is confusing, and like I said, to 99% of developers, it actually doesn't matter. Like, it's irrelevant, because you as a developer, you just want to optimize for whatever it is you want to optimize for, whether it be cheap transactions or fast transactions or secure transactions. most developers out there don't actually care about the architecture of the chain itself. So that's why kind of in my presentation, it was such a small piece
Okay.
because
Yeah.
yeah, like it's something that's less, it matters so little. So just to give you an idea, there's this concept of protocol developers, and then there's a concept of application developers.
Okay.
Protocol developers are the people who care about this stuff. They're the ones who are designing protocols. They're the ones who are designing blockchains. And for them, obviously these types of architectures and design decisions matter a lot. But for application developers, which is what I would consider myself and most, and I would say 99.9% of people on this stream, is we're application developers. We're not building protocols. We're building dApps. Like the counter is an example of a dApp. It's an application built on top of some blockchain. We didn't build our own blockchain or we didn't build a protocol. So for people like us, those details don't really matter as much. It's just not something we think about.
Okay, so okay.
It's like, oh, I want to buy a new car. You're like, I want a red car and I want it fast and I want a convertible. But you're not like, okay, maybe you are, but generally, right? You're not like
Me personally, I would not know.
I need like 7 cylinders, and I need like the connection to be like hardwired directly under the motor, not above the motor, and I need the windshield wiper fluid to be green. You know, it's like those details don't matter.
But like, where is it? Like, if it's, you said, but we wouldn't want to be at L1. That seems like a stance Fuel has taken, right? So like, where are they? Like, if I make an app with Sway, like, how should I understand where that lives and whether it can talk to Uniswap or not?
That's a great question. At the moment, Fuel is in testnet, which is basically the term that we use when it means like it's not on mainnet yet, or means that it's still like in the process. So right now, Fuel exists in a vacuum, like in terms of like it's not actually on Ethereum because it's still on testnet. And the idea, right, is like when you go mainnet, now you're actually deployed on Ethereum. So right now, it's like we're in our own world, we're in our own kind of like island over here because we're on testnet. And then one day in the future, when Fuel is like ready and it goes mainnet, then the way it would be kind of classified in developers' heads would be the same way that Optimus and Arbitrum are, as like a roll up on Ethereum.
Okay, great. That's all I needed. I was like, oh, okay. So we're not there yet, but eventually I could deploy this code that I write in Sway to the Fuel VM, which will be something like an L2 on ETH mainnet or some other configuration. That just seems like a very likely one based on how it's positioning itself.
100%.
Yeah.
100%. Yep.
Okay. So we're early. Like, Fuel doesn't even have TVL. Like, nothing written in Sway has TVL, for example. Like, none of these are.
None of these are on mainnet. None of these are dealing with real money. Correct. Yeah.
Right.
These are all like there are applications and there are protocols being built, but yeah, they're not real. Like they're not using real funds.
Yeah. Some people like being early, so I think that's a plus. What else should people know about like Fuel as an organization's like roadmap or momentum, or like the ecosystem that's beginning to gather around the tooling that you're putting out? Like, what are Fuel's priorities? What is its strategy? Why should folks put their time and effort and energy into something like this?
Yeah, I think for me, what really drew me to Fuel at first is that I knew I wanted to work like, you know, for like a better term, like a blockchain organization, like someone creating their own network. So I didn't want to work on like tooling. I didn't want to work on like all these other things. I wanted to work on, at the time in my mind, I had it framed as like a layer 1 or a layer 2 blockchain. And what really drew me to it is that instead of it kind of trying to reinvent the wheel and be like, oh, we're going to sprout up a whole new blockchain and a whole new ecosystem, it had this ethos of like, we are part of the Ethereum ecosystem and we want to support Ethereum as a blockchain. And we want to bring better tooling, better language, better developer experience to that ecosystem. So I would say like if you're kind of maybe thinking of different chains or different ecosystems, I would say it's like stay, at least for me, it's like how do I stay in the ecosystem with super strong network effects and a super strong community, but how do I then bring like a superior developer experience? So what I mean by that is literally like you can stay in the Ethereum ecosystem, but you can write in Sway. And one thing that's on our roadmap that's a ways away, but it's still interesting to talk about, is we're actually going to write a new backend to our compiler so that in some future you'll be able to actually write Sway smart contracts and deploy them directly on Ethereum. So instead of having to deploy them on Fuel as a layer 2, you'll actually be able to write Sway directly as you would right now for Solidity on Ethereum. You'd be able to write Sway directly.
Like it'll compile the contract to EVM bytecode? Or like
Yes.
it'll be like an Ethereum smart contract. It's like I wrote it in Sway, but then we turned it into after compiling
Exactly.
the thing that you would
Exactly.
deploy. Oh, cool.
Exactly. So that's something that's cool that's coming up. I think in generally, like our roadmap and our vibes are just like, let's deliver a really superior developer experience and make writing smart contracts feel enjoyable and not feel like, holy fuck, like this is so hard, this is so scary. You know, it'd be like, oh, this is
Yeah, are
actually
you
like
kidding? Well, before there was safe math, like literally if you were using addition, you were vulnerable to the overflow error, which was like an attack vector for just draining all the funds in your contract just because you had something add. It's like somebody could just call it all the way up to max value and then it would overflow back to 0 and then produce unexpected results. And then after a bunch of rugs, they were like, oops, we did addition wrong. There's this new thing called safe math and it includes like safe adding. Use that instead of adding. Like you don't want things like that. Like this is
exactly.
you said it before. Like we've learned our mistakes from the early days.
Exactly. And that's actually the whole ethos of Fuels. Like we learn from the past and we take what we learned and we actually like make those different design decisions and make different trade-offs to optimize for what we know now. You said something that brought something to my mind and then I immediately, one other cool thing, last thing I'll say about Sway that's really cool is that how many people in the chat have heard of a reentrancy attack? I'll give the chat like a second to respond.
A what
and
attack?
Reentrancy
attack.
What that is basically like a super common attack in Solidity smart contracts to the point where there's actually people who maintain a list of these attacks just I guess for fun or for posterity to kind of keep track of things that have happened in the past, where it's basically an attack where similarly like the attacker can drain a contract by re-entering a certain part of the execution multiple times in a way that they're not supposed to. So it's a super common attack in Solidity. It's something that basically I think every Solidity developer who's working with real funds knows, hopefully. And in Sway, we have a built-in reentrancy guard that at the compiler level will tell you, hey, on line 36, there's a vulnerability for reentrancy and it won't let you build, much less deploy the contract until you address that. So it's another like super big way, and that's live right now. You can use that today. It's not like one day we'll have this. It's actually out now and you can use it now. And that's again like another one of the ways in which at the compiler level, it helps you out and holds your hand instead of depending on you to be like a super genius coder.
You sharing that, like anyone who wants to become a smart contract developer, after you learn the baby steps of how to actually do anything, you immediately have to learn the kinds of things Cami and I are talking about now, which we'll call like common vulnerabilities, especially if you're working in Solidity. If you want the fun way of learning those, I encourage you to check out rect.news. Cami, you know about Rect? It's so good. Like their writing style is full on like film noir and their tone is on point. And there's 17 pages both of like CeFi hacks and straight up like DAO unravelings and all kinds of interesting stories. So if you want the lore of where things have gone wrong, I highly recommend rec.news. That's how we can look at the past and learn some lessons. But if you're inspired by some of what Cami's sharing here and thinking, okay, I want to get in there, I want to get my hands dirty, learn some stuff, and maybe like, I don't know, attend my first ETH Denver and maybe get in there. But I mean, ETH Denver's free to attend. That's very nice of them. But is there any way I could get some type of like money to be able to do that? Turns out, and this is a pure coincidence in terms of timing, there is in fact a new scholarship available today. This is coming out of a partnership between Developer DAO, shout outs to DD, and Fuel Labs, shout outs to Fuel, of course, and Fluence Project, which I will be candid, I know nothing about Fluence. Cami, do you know about Fluence? No, we don't. But they chipped in money, so we appreciate them. And so if you want to consider applying for, it's literally like $1,000 a person, and the only requirement is you go participate. It's like retroactive after you submit. It's kind of a long application, and that's for good reason. They're only going to sponsor 2 teams. So this dropped freaking minutes ago. Yeah, earlier today. I recommend you get in and apply now. I just wanted to shill an opportunity for folks to get some money to come to East Denver because like there's always this like, so now what? So if somebody is fully sold, like, thank you, Cami. Oh my God, I can finally use Rust to write smart contracts. Thank goodness. But I live in like Latin America. I'm in Colombia right now, and it would be super expensive for me to come to East Denver with all the stuff. This kind of stuff warms my heart to make it that much more accessible.
Yes, and anyone can apply. Actually, okay, maybe I'm mistaken. I think you do have to be part of Developer DAO to apply, but if you see this
You don't
opportunity,
have to be. I checked.
okay.
They were just like, yeah, we give preference, but you don't have to be.
Okay, great. Yeah.
Sorry to interrupt you.
No, thanks for clearing that up. You don't have to be part of DD to apply. You get sponsored to come out here, and the only requirement is that you hack and you build and you ship something and have one of the best times of your life. East Denver was one of the first conferences and hackathons I ever went to, and it changed my life, and it made me quit my Web 2 job and made me go full time in Web 3. So I recommend you guys come.
We got a minute. Do you want to say that in a little more detail?
Yeah, I mean, last February, I met Josh, who's here in the chat, and literally like Natter and all my homies from Developer DAO, who at the time they were just internet friends, and I don't even know if you could call them that. Like, I wouldn't even say we're nearly as close as, I mean, obviously we weren't even nearly as close as we were now. But I went there and I was so nervous. I didn't really know anyone. I was like, I'm super like in over my head. Like, these people are way out of my league. Mm-hmm. I was listening to talks and I was like, I have no idea what these people are saying, but I was like into it. And I just met a bunch of people. Everyone was so nice to me. Everyone was so welcoming. I went to my first Developer DAO like IRL meetup. We went to dinner, and ever since then I was just like, oh no, this is amazing. Like, I can't believe that there's this whole community out there of dope people working on cool stuff. And when I got home from Denver, literally, like, I put in my 2 weeks at a startup I was at the time and was like, I'm going to go full time in crypto. And the startup I was at was like, are you sure? Like, they're like, are you sure? Like, they don't really have money. Like, it's fake
What
money.
year was this?
This was last year.
So 2021, right? You're like, I'm in the 2020 bull run, or 2022. Oh my gosh.
2022. Yeah.
Yeah, we're hitting our drawdowns. Everyone's like, I knew it it was a scam.
Yeah. They're like, don't you wish you would have stayed? No, just kidding. I mean, I don't know. But yeah, you guys should come if you're kind of on the fence about coming, if you're on the fence about building. It doesn't matter if you don't have experience. It doesn't matter if it's your first time. You'll notice it's a lot of people's first time at a lot of these events. And that's kind of what makes it fun, is that like there's a bunch of loss. It's like being in high school, your freshman year, first day of school. It's like you're nervous, you're lost, but then you find out there's like 4,000 other people who are nervous and lost, mm-hmm. and then you like make friends with them, and then it's the best.
Mm-hmm. And we have a blockchain 101 area that I found out last week I'm in charge of designing. I didn't even know that. Everyone's like, Derek's in charge of that. And I was like, news to me. But it's going to be this spot up on the top floor where it's like all these infographics and like people sitting at tables to help you set up a wallet. And they're like really nice. And so we try to be newbie oriented and inclusive and intentional every step of the way. So if you're already here, if you're Beam Me Up now, if you're Exodus, if you're Josh, if you're Praying Daily, like, you're going to be there. You're going to have a good time. I look forward to seeing you. Please hit me up and give me a hug when you see me, because I'm going to be stressed. But if you're on the fence, if you're like, this stuff sounds kind of cool, but it's super confusing, like Cami said, that's imposter syndrome, and it's a normal human emotion. It's okay that you're feeling that. You don't even need to stop feeling it. But you still need to come, because it will change your life. It changed Cami's. It changed mine. It changed Josh's. I've just heard that story dozens of times. So whatever your objection is, if it's, I don't know anyone, that's fine. I'll save my story for another time about how, 2 people now. Come say hi to us. You can follow me at the Derek on Twitter. Cami, what's your handle again?
At Cami in this thing.
Cami in this thang, THANG.
Yeah.
And we would just love to see you succeed in whatever you're trying to do. It doesn't need to be coming to ETH Denver. It doesn't need to be writing contracts in Sway. I know that Cami and I are ethos aligned on like the job, the context may change, but we're here for the education and for the community and for the empowerment. So whatever we can do to help you out, just please let us know. Genuinely, hit us up. We're in the we're in the ETH Denver's server, discord.gg/SporkDAO. You can hit us up in DD. We're both in DD. We try to make ourselves pretty easy to find. We're public facing. See, we're facing you. No, this is my back end. That joke's done. That's how you know the stream's done. All right, thank you so much for coming, Cami. Anything else you want folks to know before we're out of here? Where they can what to look at next? Anything like that?
Yeah, just let me see. I can post Fuel's Twitter handle. This is like a really good place to keep up if you're interested in fueling. You're just like, I want to maybe passively just kind of know the vibes, know what you guys are working on. Fuel Twitter's a good place. I'll also link my Twitter. I mostly shit post, but every once in a while I post something really good.
Okay.
Yeah.
I'm going to chill one last thing I almost nearly forgot, and then I was going to really beat myself up. Congratulations, everyone. You thought opportunities were abundant. I got another one. I am proud to announce Camp Biddle, powered by Chainlink. We got Chainlink, we got Austin Griffith, we got Consensus folks, we got WAGME folks in here planning basically a boot camp during ETH Denver. And so if you're trying to come to ETH Denver anyway, and you can commit to being there all 10 days of Biddle Week and the core event, it's free. All you got to do is show up to the whole thing. This is not a la carte, okay? You got to apply and all that. And then you come out of it being ready in one of these 4 sick-ass tracks. We got the smart contracts, the front-end people, the community marketing team, and the design team. We need more designers, specifically designers. You don't even need to have a design background. If you don't know how to use Figma, this is for you. This is newbie-oriented. We only have room for 250 folks, and we already have 477 applicants. The good news is I haven't accepted anyone yet, so please get your application in right now. I would love to see you there if you can commit to being there all 10 days. If you have any questions about that, go to ethdenver.com/Camp Biddle and read it first. Don't just send me your questions. It's a pet peeve of mine when people don't read. But that's life, isn't it? I'm just copy pasting the Twitter links you gave. Do you have any inspirational words for folks on our way out?
No. Not really, no. Just do you in general. That's my inspiration. Just do you. Yeah.
You heard it here first. Just do you in general. Cami, genuinely thank you. This has been very fun. This lights me up, and I hope we can do it again in not too long. But in the meantime, I appreciate you and everything that you're doing out here for folks.
Love you. See you guys all in Denver.
See you in Denver. Oh, and then how we always end these, I'm going to ask you to tell the entire stream, bye.
Bye.
Thank you. And then paste link in the chat for the question. Bye, everyone.